Hello everyone, I am Malaika Dmello from St. Xavier's College, currently in my SYBSc, and today we are going to deep dive into the colourful world of chemistry, looking into indicators, acids, bases and the pH scale. So that brings us to our first question. What is an indicator? Indicators are substances which indicate the acidic or basic nature of the solution by the color change. There are many types of indicators, but some common types are natural indicators, olfactory indicators, and synthetic indicators. Indicators obtained from natural sources are called natural indicators. Litmus, turmeric, red cabbage, and China rose are some common natural indicators used widely to show the acidic or basic nature of substances. Substances which change their smell when mixed with an acid or base are known as olfactory indicators, for example, onion, vanilla, etc. Indicators that are synthesized in the laboratory are known as synthetic indicators, for example, phenolphthalein, methyl orange, etc. Under natural indicators, litmus, which is derived from lichens, comes in two colors of litmus paper, blue and red. An acid turns blue litmus paper red, while a base turns red litmus paper blue. Secondly, the juice of red cabbage is originally purple in color, which turns reddish with acid and greenish with base. Looking at olfactory indicators, the paste or juice of onion loses its smell when added with a base, while it does not change its smell with an acid. Looking at vanilla, the smell of vanilla vanishes with a base, but its smell does not vanish with an acid. Lastly, with synthetic indicators, phenolphthalein is a colorless liquid, and it remains colorless with an acid, but turns pink with a base, while methyl orange, which is originally orange in color, turns into red with an acid and turns into yellow with a base. That brings us to the next question. What is an acid? We must remember that acids have a few typical characteristics, like acids have a sour taste, they turn blue litmus red, an acid solution conducts electricity, and it releases H plus ions into an aqueous solution. An acid, which is completely ionized in water and produces H plus ions, is called a strong acid. A few examples are hydrochloric acid, which is HCl, sulfuric acid, which is H2SO4, and nitric acid, which is HNO3. While an acid, which is partially ionized in water and thus produces a small amount of hydrogen ions, is called a weak acid. For example, acetic acid, which is CH3COOH, and carbonic acid, H2CO3. Did you know that when a concentrated solution of acid is diluted by mixing water, then the concentration of hydrogen ions or hydronium ions per unit volume decreases? Now let's look at the two main kinds of acids. We have natural acids and mineral acids. Acids which are obtained from natural sources are called natural acids or organic acids. Examples are acetic acid and citric acid, while acids that are prepared from minerals are known as mineral acids. Inorganic acids, man-made acids, or synthetic acids are also known as mineral acids. For example, sulfuric acid and phosphoric acid. That makes us question, what is a base? Similar to acids, even bases have some typical characteristics, like they have a bitter taste, they turn red litmus blue, they conduct electricity in solution, and they release OH- ions in aqueous solution. A fun fact about bases is that they are soapy to touch. It is important for us to remember that strong bases are completely ionized in water, producing hydroxyl ions. Potassium and sodium hydroxide are examples of strong bases, while weak bases are only partially ionized in water. Thus, they tend to produce a small amount of hydroxyl ions. For example, ammonium hydroxide and pyridine. Now, since we've already looked at indicators, acids, and bases, that brings us to our fourth question. What is pH? pH is a quantitative measure of the acidity or basicity of an aqueous or other liquid solutions. This term is widely used in the fields of chemistry, biology, and agronomy. With the help of pH, we can find out the concentration of hydrogen ions by using the following formula, where the value of pH is equal to the negative log of the hydrogen ion concentration. So let's take a short trip through history and look at how the concept of pH was born. It was first introduced by the Danish chemist Søren Sørensen at the Carlsberg Laboratory in 1909, while much later, in 1934, Arnold Orville Beckmann, who was a professor at the California Institute of Technology, developed the first electronic method for measuring pH. Fun fact, did you know that Arnold Orville Beckmann was motivated to develop the electronic method of pH determination in response to local citrus grower Sunkist that wanted a better method for quickly testing the pH of lemons that they were picking from their nearby orchard? After that fun trip through history, let's take a look at the pH scale, which is used to specify the acidity or basicity of an aqueous solution. We must remember that solutions having the value of pH equal to 0 are known to be strongly acidic solutions, while solutions having a value of pH ranging from 0 to 7 on the pH scale are termed as acidic. Solutions having the value of pH equal to 7 on the pH scale are known as neutral solutions, like pure water. And for the value of pH ranging from 7 to 14 on the pH scale are known as basic solutions. Lastly, solutions with the value of pH equal to 14 are termed as strongly basic solutions. That makes us wonder, is it really possible to see these colors of chemistry right from our home? Yes, we can, by preparing our indicators from household ingredients like lemon juice, orange juice, or even detergents. We too can study the colorful world of pH. So let's take a look at some of our requirements. To perform this experiment, we will require red cabbage, citrus fruits like orange and lemon, laundry detergent like Rin and Surf Excel, vinegar, baking soda, shampoo, and water, along with some bowls and spoons. In order to conduct this experiment, we have to prepare a red cabbage indicator using its leaves. Not only is the red cabbage indicator easy to make, but also exhibits a wide range of colors. Red cabbage contains flavin, which is an anthocyanin, and an encounter with a highly acidic solution would turn it into red, while basic solutions, it appears greenish blue. We must take about 5 to 6 leaves of the red cabbage and cut it into smaller pieces for easier handling. After transferring the red cabbage, we must add water just enough to cover the leaves. After heating it on a flame for approximately 5 minutes, we can allow it to stand for about 12 to 15 minutes and pour this into a container to be used as our indicator. Our first solution being tested is vinegar. On adding our pH indicator, we obtain a deep red color. On referring to the pH scale, we can infer the pH is equal to 1. For our second solution, we obtain a bright red color on adding our pH indicator to the juice we obtain from juicing our lemon. Hence, we can infer the pH is equal to 2. Next, we obtain a dull reddish brown color on adding our pH indicator to our juice solution which we obtain from juicing in orange. Hence, on referring to the pH scale, we can infer the pH is equal to 3. Our fourth solution is shampoo. On adding our indicator, we obtain a color slightly lighter than our purple pH indicator, similar to a lilac or a lavender. Hence, our pH is equal to 6. Our next solution was water. On adding the purple pH indicator, there was no such color change observed, and hence, the water was determined to be pure of pH 7, hence being neutral. Our sixth solution was baking soda. On adding our purple pH indicator, we obtained a deep turquoise-like color. On referring to the pH scale, we infer that the pH obtained was 10. Surf Excel was one of 2 detergents that we tested. On adding the indicator, we obtained a dark green solution. On referring to the pH scale, we infer that the pH was equal to 12. While in the case of Rin detergent, on adding our purple pH indicator, we obtained a lighter lime green-like color, and hence, on referring to the pH scale, we could infer the pH was equal to 13. With all our colorful solutions finally prepared and our control being the purple pH indicator, we can conclude that vinegar, lemon juice, orange juice and shampoo are acidic solutions, while baking soda, surf excel detergent and Rin detergent are basic solutions, with water being a neutral solution. And finally, let's look at the importance of pH in our daily lives. Determination of pH in our digestive system is very important, as dilute HCl helps in digestion of food in our stomach. Excess acid buildup in our stomach causes acidity and indigestion. Therefore, antacids like milk of magnesia and baking soda are used to neutralize the excess acid. Tooth decay can easily be caused by acids, as the bacteria present in our mouth converts the sugar into acids. When the pH of acid formed in the mouth falls below 5.5, the tooth decaying starts. Hence, the excess acid has to be removed by cleaning the teeth with a good quality toothpaste, because these kinds of toothpaste are alkaline in nature. Finally, the pH of soil is very important for plant growth, as most of the plants have a healthy growth when the soil has a specific pH which is close to 7, which should be neither alkaline nor highly acidic. For more information on indicators, acids, bases and pH, you can refer to the following links. Thank you for watching. I hope you enjoyed a little insight into the colorful world of chemistry.